Hello, this is Stefan again from schristoph.online. Today we'll talk about my latest blog post, Your Obsidian Vault is a Knowledge Graph. The claim is simple. A folder of markdown nodes linked with wikilinks and tagged with frontmatter already is a semantic knowledge graph. Wikilinks are edges, frontmatter is typed properties, folders are namespaces, no graph database required to start. For a long time I thought of my nodes and my agent as two separate things. The nodes for storage. The agent was intelligence, that framing is backwards. And a post by Tony Seal made me say so out loud. Seal spent 6 months working almost entirely inside a markdown wiki, wired to a language model, and argued the markdown is not a passive store the model dips into. It is the model's memory. So what actually makes something a knowledge graph? At its core, three things. Nodes, the things, edges, how they relate, and properties, facts about each thing. Now look at a linked vault. Each node is a node, each wiki link is an edge, the frontmatter block is a set of typed properties, and folders are namespaces. That is a graph, not a metaphor for one. Here it is as a picture. 3 nodes connected by wikilink edges, each carrying frontmatter properties. The triples are right there. This node links to that node. The only thing missing compared to a formal store is a strict ontology and a query engine. And as we'll see, you do not always need either. Here is the interesting part. The prose in a node is a neural representation. Fuzzy, contextual, the kind of thing a language model absorbs. The structure around it, the links and typed properties, is a symbolic representation. Discrete and precise, the kind of thing you follow deterministically. This is the neuro-symbolic bridge people chased for years, and Seal's claim is that it turned out to be unglamorous. The boring version were. Where does this land in agent memory? IBM's write-up drawing on the koala paper splits long-term memory into episodic, procedural, and semantic. Semantic memory is structured factual knowledge, the layer an agent retrieves from to reason. A linked vault is a clean fit for that semantic rung. The top of the memory spectrum I mapped out in part 1 of this series. Let me switch to that source. This is IBM's overview of AI agent memory, drawing on the koala paper. It defines semantic memory as structured factual knowledge implemented with knowledge bases, symbolic AI, or vector embeddings. That is exactly what a structured vault is. The taxonomy is IBM's and koala's. The vault as graph framing is mine. This is not a thought experiment. My own working setup is Kiro CLI, a terminal coding agent reading an Obsidian vault as its backbone. When the agent prepares a meeting, it starts at the meeting node, follows the wiki link to the customer node, follows that to the relevant research, and reads frontmatter to know what each node is. That is graph traversal. A link I write for myself is unchanged, an edge the agent follows. You might ask, isn't calling a folder of nodes a knowledge graph just rebranding? A graph database does far more fair. A linked vault genuinely has nodes, edges, and properties, which is the structural definition of a graph. What it lacks is a query engine and an enforced schema. So the honest claim is narrower. It is a graph you can traverse, not one you can query at scale. Here is where I have to be careful, because the easy version of this argument overreaches. Markdown does not replace graph databases, it replaces reaching for one too early. A linked vault struggles the moment you need queries across the whole graph. Scale beyond a working set, a strict enforced schema, or many concurrent writers. Those are exactly when a real graph store earns its place. So the obvious objection, this only works because your vault is small, correct, and the post says so. Traversable reading is fine for thousands of nodes and a single reader. It breaks on millions of entities, cross-graph queries, and many concurrent writers. The honest rule is a maturity ladder, not a rivalry. Start with the graph you already have, graduate when you hit those walls. The pattern is tool agnostic. But here is where each rung lands on AWS, following the same ladder. The graph you already have is files in Amazon S3 that the agent traverses, managed semantic memory, is Amazon Bedrock knowledge bases, with a graph rag option backed by Amazon Neptune Analytics. A real graph database is Amazon Neptune. And AWS announced AWS Context at the New York Summit coming soon, which extends a personal knowledge graph into a governed organizational one. Here's the top rung, Amazon Neptune, the managed graph database. It supports both property graph and RDF with OpenCipher, Gremlin, and SparkYAWL for traversal and query. This is where you go when you need cross-graph queries, enforce relationships, and scale. The things the Markdown Vault cannot give you. You grow into it, you don't start here. The takeaway, you do not need to stand up a graph database to give an agent a knowledge graph. If you keep linked, tag nodes, you already maintain one, and the structure you added for your own benefit is the structure your agent traverses. So before you reach for Neptune or a graph store, open your nodes and ask, is this already the graph I was about to go build? Thanks for listening. I hope this was helpful. If so, you can reach out on LinkedIn directly or head to my blog at schristoph.online. Let's keep in touch. Take care.